Okay, I assume we're gonna finish up this sheet here.
No. So today it's on the website.
Oh, okay. Big ideas?
Yes.
Unimpressed with their website. It is Common Core High School, right?
Yes.
There we go. What page?
266.
Sounds like you got a bit of a cold there. Hope it's not the flu.
Yeah, I don't know. Just started feeling it today.
Hmm. All right, which of these problems?
So we'll start at let's see here. 16. And then he chose individual problems. So
Okay. How are we going to do 16? Is that big enough for you to read? Hold on a second.
yes, that's fine.
First step.
So let's see what is it? Okay. Uh add 10. Oh wait, no. Square both sides.
Correct. In other words, when you see a radical sign, you want to isolate it and then immediately square both sides.
Right.
Okay, well, it's already isolated here. So what do you get after you square both sides? Tell me the next line.
Um, x squared, or yeah, x squared um, minus 20x plus 100.
That's a neat trick to be able to square those without having to actually FOIL it. And I presume that's what you're doing, right?
Yeah.
In other words, you've memorized what a plus b squared is, then a minus b
Yeah.
squared. Okay, next line, let's simplify it. That's a 9x over on the right.
So x squared minus 29x plus 100 equals 0.
So, next step is the factor.
Right.
We know it's x and x. What are both signs?
Negative.
Okay. Now, factors. What's the next rule?
um, so, thank you.
In general, what's the thing we're looking for next? And it's the
Uh,
last step.
it's what multiplies to 100 to get and adds to negative 29.
Okay. Or just it needs to add to 29. You don't need to concern yourself with that negative. We've already taken care of that negative with these two negatives here.
Okay.
So we're looking for factors of 100 that add to 29. Well, that sounds like it's going to be difficult to get, right?
Yeah.
Okay, so let's go through factoring. How do I factor a number manually?
So 2 and 100.
Well, no, it's always 101.
Oh,
That's where
yeah.
you begin. Okay. In fact, for some reason, I find it better to put the 100 on the left. And I'll tell you why. Because my next step is going to be to try to cut the 100 in half. If I can do it, do it. So what's the next two factors?
So 50 and 2.
Next two factors.
25 and 4.
Next two factors. I can no longer cut 25 in half. Can't cut it in a third, but I can cut it in a fifth. So what's the
Right.
next two
Oh,
factors?
5 and 5.
Now, if I cut this in a fifth, I got to multiply the 4 by 5. So it's 5 and 20. Now, I can actually go the other direction. I can cut the 20 in half. And I can get 10, which means I got to double the 5, and 10. Now, you see any factors? We could have stopped when we got to the third one, but I wanted to go all the way to the bottom just to show you that you can do either side, try to cut it in half. And occasionally it'll give you two different factors like we got in the last step. What were we looking for? Two factors that added to 29. Which two add to
Yeah.
29?
25 and 4.
Okay. So that's how you do that. And you can probably be relatively certain they're not going to give you something that requires the quadratic here. Because when you first look at this, it looks like, man, that's going to be hard to find factors of 100 that add to 29. So why don't I just skip trying and go straight to the quadratic? Probably not. I'm guessing that every single problem on this page we can use and solve without the quadratic.
Okay.
Now, what's the next step?
Um, so uh, put it equal to 0. Each one
What's
equals
the next
0.
line? Okay. What's the next line?
So x equals 25 and x equals 4.
Are we done? No, we're not. Whenever you see a radical sign, then you always have to check both solutions. There's a good likelihood that one of these solutions will not work.
Okay.
Which one can I figure out's not going to work instantly?
25.
No?
4.
4. Notice why. 4 makes this side negative. Well, you can't take the square root of a number and get a negative number. So there's no way that 4 works. You know what I'm saying?
Yeah.
Instantly, I can see that if I plug 25 in for x, the left side's positive. The right side's positive, that's going to work. But if I plug in 4 for x, the left side's negative. Well, that can't be. You can't take the square root of anything and get a negative number. So it's impossible for the left side to be negative. So we immediately can rule out that one. And now we really don't have to test the other one. We don't have to spend our time testing it if we don't want to. We could, and we'll get 15 equals the square root of 225, and that is a true statement. So 25 works. But once you found the one that didn't work, you kind of know the other one's going to work. So you could just go on to the next question if you were pressed for time. Okay,
Okay.
what is the next question?
Number 21.
Okay. First step?
So
What's the next line?
4x plus 1 equals x plus 10.
Why is this problem on here? Okay. What's the next line?
So subtract what?
Just give me the next line.
Oh, sorry. So 4x equals x plus 9.
And the next line.
Uh, 3x equals 9.
And the next line.
X is 3.
Okay. If we plug that in, I would be surprised. Since we only have one solution, it almost has to be correct. Unless it gave us a negative argument inside the radical, then there would be no solutions. Okay, but it doesn't. It gives us square root of 13 equals square root of 13. So that's fine. Okay, next problem.
So it is 22.
Okay, next first step.
So where's 22? There. So square, or wait, no.
Remember, before you do that step where you square both sides, you got to isolate at least one of the radicals.
Right.
In other words, I can't, well, that's a bad example to pick. Let me see another one here. Yeah, we'll deal with those when we get there. All right, but I've got two different radicals here. One's being subtracted from the other. If I
So
square both sides, I'm still going to have a radical left. So that's not a very good strategy. Plus, the math is hard.
yeah. So I guess add the square root of x plus 12.
Yeah, and then it becomes a clone of 21, right? In other
Yeah.
words, once I move one of the radicals to the other side, then the problem looks exactly like 21. Next line.
So 3x equals 3, or minus 3, sorry, equals x plus 12.
Next line. This time do both steps in one. In other words, don't do the number first and then the variable second. The reason I want you to do that is because at this point, you have to make a decision. The goal is to get all your terms with x in them on one side, everything with numbers in it on the other. So you have to make a decision right now as to which side you want your variable on, which means the number is going to go on the other side. Since you have to make both of those decisions, let's just do both steps at once.
Okay.
Rare that I recommend that. But when you're dealing with this situation, I think it lends for a better understanding. I noticed last time when we did 21, we had a little difficulty with what to do with the x's.
Okay.
So first of all, which side are we going to put the x's on?
The left.
Correct, because you want a positive coefficient. So we're going to put the number on the other side. So do both steps at once. How many x's do I
So
have on the left?
2x,
How many numbers do I have on the right?
15.
All right. and again makes x equal to 15 halves. And as long as that's not a negative number, and it isn't, then these are going to be correct. And you don't really need to check it. I would say don't spend your time checking for extraneous solutions unless you get two solutions. Well, these problems were only getting one solution. Yeah, okay. Next problem.
25.
Okay. First step.
Subtract, well, actually, square both sides because one.
Okay,
Right.
now this gets a little tricky. You got to square that. The right side's going to give you x plus 5, right?
Right.
In other words, when I square that, square the left side. Using the same rule. What's the first term going to be?
The square root of 3x minus 8 squared.
Which is?
3x minus 8.
Okay, so it's not as hard as we thought. Now put it in parentheses just for clarification. What's the middle term?
Square root or plus the square root of 3x minus 8.
Remember what you'd happens when you have a plus b quantity squared. The answer is a squared plus 2ab plus b squared. In our case, what is 2ab?
2 times the square root of 3x minus 8.
Correct. And what's the next term?
1 plus 1.
Plus 1. Outside that radical. Okay? Now notice what's happened. We started with a problem that had two different radicals, and by squaring both sides, we eliminated it to one radical. So now what's our next step going to be from here? If I gave you that as a problem straight away, what would you do?
Well, you can add, so 3x minus 7 if you add the 1. So, and then you can subtract 3x and then add 8.
No? The goal, remember, is to always isolate the radical sign. So, and then get everything else on the other side, and then we're going to square both sides again. And that's always what happens on these. In other words, when you square both sides where there's two radicals, you end up with one radical, which is what we have now. Now we got to isolate that radical, which means I got to move that to the other side. I got to divide by 2 also. So let's start by moving the 3x minus 7 to the other side, which is going to leave 2 square root of 3x minus 8 on the left. What's the right side going to be?
Negative 2x minus 3.
Got to add 7.
Ah, crap. Yeah, 2 minus 2.
I'm adding 7. I'm not subtracting 7. Right now, the 7 is being subtracted. So I got to add 7. So it's plus 12. In other words, words, I subtracted 3x, right? And I add 7. You always do the opposite of what it's doing. Okay.
Okay.
Now what's the next line?
The square root of 3x minus 8 equals negative x plus 6.
Okay. Now what's the next step?
So, square both sides?
Correct. Now, I know what the left side's going to be. 3x minus 8. Squaring this is a little tricky, but if I rewrite it as 6 minus x, then we can use a minus b squared, and it'll be easy. Okay, so I've got 3x minus 8. Now square 6 minus x using this formula up here.
Okay. So 6 squared, so that's 36. So 3x minus 8 equals 36 plus or minus 2x.
Not 2x. 2 times 6 times x. 12x.
Okay.
2 times 6 times x. Only I'm using the negative one. Okay.
Right.
And what's b squared?
X squared.
Plus x squared. I need the plus. I definitely need the squared. Okay. Now we're looking at a quadratic. Correct? I've got an x squared term, I got some amount of x's, and I got some amount of numbers. So over here on the far left, give me what the next line is.
So
I'll get you started out. 0. Because it's a quadratic and we have all 3 pieces of the quadratic, we're going to make one side 0 and put everything else on the other side. And the reason I chose the right side is because the x squared term already has a plus coefficient. And we know it's going to turn into a factoring problem, so we want that. We want a plus coefficient in front of the x squared term.
okay. So
Let's put it in order.
So
Proper
x
polynomial order.
So 0 equals x squared minus 15x plus.
Oh, are you getting 15x?
Yes.
We got, oh, excuse me. Sorry. I had these backwards. Okay, that's correct. Minus 15x. And then what's the number?
Plus 44.
Okay. You shouldn't take that long to do it, especially if you have a calculator in front of you. If you're not comfortable with being able to do that in your head quickly, then immediately use the calculator. You'll get an answer quicker. And speed's going to be important. So if you have any doubts whatsoever as to the accuracy of your answer, just use your calculator. Now, factor this. Next step.
So minus both of them.
Concept of the last step. What are we looking for?
Factors of 44 that add to 15.
Okay. I don't know what they are yet, so let's just go through the process. Give me the next set of factors.
22 and 2.
Next one.
11 and...
Okay, you cut 22 in half. So all you have to do is double 2.
Oh, 4.
You don't have to do any math here other than doubling 2. You don't have to make sure that 4 times 11 is 44. That has to be true. If you've cut 22 in half and doubled the other side, then these two have to multiply to 44. And that's the easy way to do it, as opposed to figuring out 11 and then dividing 44 by 11 to get the other number. That's the hard way to do it. And that's our answer. We just found our two numbers.
Okay.
Now, this one is so complicated that, what do I have? We had x minus 11 times x minus 4.
Yep.
Which makes our answers what?
X equals 11 and x equals 4.
Okay, let's see if we can rule one of those out instantly. What are we doing? We're doing 25?
Yes.
Is one of those numbers going to give us problems? Don't see it. By giving us problems, I mean, will one of those answers produce a negative argument under the radical? And no, it doesn't. So let's check both answers. Let's do the easy one first. Plug in 4. What do you get?
So the square root of 3 times 4
So
minus
12 minus 8, which is the square root of 4 plus 1. Is that equal to the square root of 9?
Yes.
Okay, now let's plug in the other one. And the other one almost guaranteed is going to work also. Sometimes I'm surprised, but 3 times 11 is 33 minus 8, so it's the square root of 25 plus 1. Is that equal to the square root of 16? I'll be darned. That one doesn't work. Hold on, let me give myself enough room to write it properly. We got the square root of 33 minus 8, which is 25, correct?
Yes.
Plus 1, and that's supposed to equal the square root of 16. That is not true. That's 6 equals 4. So the 11 does not work. And yet the fact that it didn't work was not obvious. It didn't work not because it produced a negative argument. It didn't work just because it didn't work. 11 is not a solution to that problem. Not unless I'm doing something seriously wrong. 33 minus 8 is 25. Square root of 25 is 5. 5 plus 1 is 6. 11 plus 5 is 16. Square root of 16 is 4. So the 11 doesn't work. That's a good lesson. It tells us that you got to be really careful with these. You can't just do the overall test of seeing whether it creates a negative number under the radical. What next?
26.
Okay, first step.
So square both sides.
Okay, give me a line.
So x plus 2 equals
Again, do it using the a minus b squared. You know what I mean by that, right?
Yeah.
Okay.
So, so for
Always write what you know has to come next. Do I have to have a negative sign or a positive sign next?
negative.
Okay. So write the 4, write the negative, and then start thinking.
So -4 square root of x.
Yeah.
Then plus x.
Okay. Good. Now what?
So so
Notice
z
one thing here. When you see that and that, what can you do immediately?
get rid of the x.
Just cancel them. You don't even have to think about it being subtracting x from both sides. If I've got the same sign and the same coefficient and none of them's a multiplier, then I can just cross them off. Okay? Now, next line. At this point, I've got 2 equals 4 minus 4 root x. Next step.
So subtract 2. So that's
Hold on. This is not a quadratic. This is not going to be where we get 0 on one side and everything else on the other. This is going to be where we're trying to isolate square root of x.
okay.
We want square root of x all by itself on one side or the other. I don't care which side.
So it's -2 equals -4 square root of x.
Okay, next line.
Negative. So 2.
Okay, what's
Right?
the next step? We're trying to isolate square root of x. There's something in the way. There's this -4. What is that -4? Is it a multiplier, divider, adding, or subtracting?
It's a multiplier.
Okay, so how do we get rid of it?
Divide.
Okay, by dividing both sides by -4. Now, that gives us square root of x on the right. What do we have on the left?
1/2.
Okay, and then finally, we finally got our square root isolated, so now we're going to square both sides.
So
What's 1/2?
I need
What's 1/2 squared? One half
1.
times, no, I didn't say what's 1/2 added to 1/2. When I said squared, it's multiplied. It's 1/2 times 1/2. What is 1/2 times 1/2?
1/4.
Okay. When you're multiplying fractions, you just multiply the numerators, multiply the denominators. Okay, so there's our answer. And even though we only have one answer, this was a little bit of a screwy problem. So I'm going to test it. Make sure we don't have anything unusual going on. Well, if I plug in 1/4, I've got the square root of 2 1/4, which is 9/4. Is that equal to 2 minus the square root of 1/4? Is that a true statement? It's the square root of 9/4. And I put it in an improper fraction for a reason. Both of those are perfect square numbers. So what's the square root of 9/4?
3/2.
Okay. What's the square root of 1/4? It's a little tougher.
One 1/2.
Uh-huh. In other words, the reason that's tougher is people are used to taking square roots and getting smaller numbers, right?
Yeah.
When you take the square root of a number less than 1, you get bigger numbers. Goes the other direction. And yes, that is a true statement. Therefore, that answer is correct.
Okay.
And what else?
That's it.
Okay. Any other questions or anything?
No.
Dimitri, I will talk to you next Tuesday at 4.
Okay.
Okay, bye-bye.
Bye.